All right, so we're now opened up to the next two clean pages in our spiral. We're on the even page. We're going to be taking our notes. Our notes are for lesson 1-4. And since we are taking a quiz on Tuesday, this is the last of the material that you're taking a quiz on. So it's lessons 1-1 through 1-4. So our notes today are on the distributive property. No, let me take that back. Let's give it its due course with the capital T-H-E, the distributive property. And the reason why it gets that title is because yesterday I mentioned it is the most important property in all of algebra. Without it, we would be stumped in solving many, many problems. So the distributive property, today's date is, 10/2/15. Okay, so we're on the even page. So let me give you a couple of examples of what the distributive property is. So we get to do a little drawing. My daughter and I have discovered that we don't do so well with ice cream anymore. So our new favorite thing is popsicles because it doesn't have the dairy in it. So we seem to be able to handle that better. So we're always trying to figure out when do we get our next popsicle. And our favorite one right now is one from Trader Joe's that layers strawberry and lemon and raspberry. It doesn't sound good. It is good. It's delicious. Okay? Now, I want my own. She wants her own. So what we want to do is share popsicles so that both of us get our fair share. So there's me. And you can tell. Yes. You can tell it's me. Am I drawing?
No, are we drawing this?
Am I drawing?
Yes.
Then you're drawing. So that's Miss Rosner. And we've got little Minnie Me. Who, if she had her way, would be Rapunzel. And she likes to wear her hair in a side ponytail, which makes me laugh because that is so 80s coming back. And she likes the color purple, so we'll make her little dress purple. So that's Tiana, which her nickname is T. So we open up the box of popsicles and we distribute the popsicles to each one of us. So what ends up happening they're like expensive for $4. You guys have to do something really amazing for me to get you popsicles like that. Okay? And what ends up happening is when I open up that box, I get a popsicle. Shh. And Tiana gets a popsicle. And a purple dress. Shh. There's a lot of conversation going on. So this is basically the distributive property in action. Each person got what was being offered. Okay? I'll show it to you a different way. Let's do it like this. Oh, I see. I have a D plus an I, and then in parentheses an STR plus a BUTE. What I'm going to do is exactly what I did with that popsicle. Each of these bundle of letters is going to get that I. And what I end up getting is the word distribute.
Oh my gosh, that's so clever.
Thank you, Pinterest. Okay? And that's really what distributing is. It's taking what's outside, parentheses, grouping symbols, and sharing it with everything inside. Okay? That's the key idea behind the distributive property. Okay? So let's write that out in words, and then we're going to go ahead and do a couple of examples on the other side. So I'm trying to think if sometimes I don't like what the book says. In fact, the book doesn't say much of anything. So to distribute, you're going to multiply everything, or no, let's use some mathematical terms. Everything's not very good. Each term inside the parentheses by the value outside the parentheses. Okay? So that's what distributing is. Take what's inside or outside the parentheses and to multiply it by what's inside the parentheses. So I'm going to go to the odd page for the examples. And the kinds of directions that you would hear would be simplify. And this direction means simply do all the math you can do until there's no more math to be done. Jack, let's have you move over here at the table by yourself so that you can focus. So to simplify, now please. You're Jack, yes. Over there. With your stuff, so you can take notes without being distributed, or disturbed. That too. So to simplify, you would have something like this. 7 times x plus 3. Since we can't add x and 3, that's where the distributive property becomes so important. So what you're doing is multiplying the 7 times the x, and then whatever operation is inside comes outside, and then you're going to distribute the 7 times the 3. So that's basically what I call a brain step. The result is you get 7x plus 21. Okay? So it's an actual process. Now, I want to go back to the notes section for a moment. I'm going to have to go to the new page for that because I ran out of room. And my question is, with the other operations we talked about, properties on Wednesday, we talked about one operation happening for each problem. So when we talked about commutative, there was either addition or there was multiplication. When we talked about association, it was either all addition or all multiplication. All the properties dealt with either just addition or just multiplication. What do you see going on with the distributive property when it comes to operations? Yeah. It has two different ones, right? And that's what makes the distributive property so unique. So again, with the distributive property,
This is notes, right?
Yeah, this is on the even side. Deals with two operations. Always multiplication and either addition or subtraction. Okay. And we just make sure that whatever's outside gets multiplied by everything inside. Okay, so distributive property deals with two operations. Always multiplication is one of the operations, and then it could be either addition or subtraction. Okay, you're not going to have multiplication or division inside the parentheses. You're either going to have adding or subtracting, or you could have a combination. How could you have a combination of adding and subtracting inside of parentheses in a distributive property problem? Can somebody come up with an example that we could put in our notes that would have both adding and subtracting? So I'm going to go back to the example page. Any ideas how I could have both operations inside the parentheses? Michael? Okay, I don't need brackets. Parentheses are good for us here. How many terms do I need in order to have at least two different operations?
4.
Okay. I need a minimum of 4, Patrick?
Yeah, 4.
I need 4? Do I have to have 4? Joy? I need a minimum of 3 things, right? So I could have 2x plus y minus 3. The number of items inside the parentheses makes no difference in how the distributive property works. It's the same. It works the same all the time. So we're going to distribute the 5 to the 2x. And then the operation says plus. And then we're going to distribute the 5 to the y. And then the operation says subtraction. And then we distribute the 5 to the 3. 5 times 2x is 10x. 5 times y is 5y. 5 times 3 is 15. So you're not limited to only 2 things inside the parentheses. You can have as many things as you want. Minimally 3 if I want to see 2 different operations. But I'm only going to see adding or subtracting inside, and there will always be multiplication with the guy outside. Without multiplication, it's not distributive property. Michael?
You're not supposed to solve that.
You can't, right? Unless I said distribute to remove parentheses, then if x equals 2 and y equals 3, what's the value of that expression? That would be the only way to solve it. That it follows the directions of simplify. We're done. Okay? Lainey.
Number 1 can't be solved because it's 3. Right?
Number 1 can't be solved either because I don't know what x is. So what all the directions tell me to do, they don't ask me to evaluate, which is what you guys are asking when you say, can you solve it? They're just asking me to simplify. And the only way to simplify, if you can't do the math inside the parentheses, is to distribute to get rid of the parentheses. Okay? Now, I do want to share one more that for some reason throws everybody off. Let's say we have this. 6v squared plus v minus 3 times 4. So I have parentheses, I have only adding or subtracting going on inside, and I have a number outside the parentheses. How do I solve this one? How do I solve it when the number's in the back? How does that change things? It doesn't change it at all. I'll tell you honestly, this is the one most missed question that I see on quizzes and tests. For some reason, putting it in the back freaks everybody else out. But what property did we talk about that I could use on this problem to put that 4 in the front, what makes me more comfortable? Because I'm a creature of habit. Michael? Commutative. The commutative property of multiplication says I could put the 4 in front of the parentheses. It's the same thing. So here's how I do it. I just go ahead and I multiply always towards the first term inside the parentheses. So I get 4 times the 6v squared, and then it says plus, and then 4 times the v, and then it says minus, and then 4 times the 3. And the answer is 24v squared plus 4v minus 12. Okay. So what you're seeing in color, that middle step, should be done in your head. I call those brain steps. That should be happening in your brain. Though I'm going to tell you, I'm going to highly recommend you draw the connector and do the math and write the answer down. Because what I see, so I would do 7 times the x, that's 7x. Plus 7 times the 3, that's 21. Without those connectors, people drop off stuff all the time. Okay? Now, related to this is one other problem. And this would be something you would have seen more in an elementary setting, is let's say that you were trying to do this problem. Okay, so what some people recommend is you think about this outside the box, and you think about a different way of doing this math without doing 49 on top, 7 underneath, do long multiplication. Is can we think of 49 in a different way that's going to make my math easy? Well, the way I want to always think of numbers to make my math easy is to think of a number that ends in a 10. So some kids would say, oh, I could break 49 into 40 plus 9, and I can multiply each of those by 7. But I got even a better way. Lainey?
You would do 7 times 50 and then subtract 7 from it.
So here's what we're going to do. We're going to take that 49, and we will write it as 50 take away 1. Okay? Then when I distribute, I have 7 times 50, and then minus 7 times 1. So in your head, 350 minus 7 is not so challenging compared to 7 times 49. Okay, and so then we end up with 343. Okay, so again, another way of using the distributive property. All right, the other main thing we're going to talk about, not quite yet, there's 3 things that you can do when it comes to the distributive property. The first one is to distribute, to remove the parentheses. The next one we'll talk about in a little while is to put the parentheses back in. So we have to see what do those numbers have in common that I can pull outside. That's called factoring. But the other one we want to talk about is combining like terms. So first off, we need to know what the word like terms is. What are like terms? Anyone know? I'm going to highlight that guy in yellow. Okay, Michael?
Like 2x plus 3x.
Okay, so he gave me an example of 2x plus 3x. He's absolutely right. Those are considered like terms. Can somebody in words tell me what like terms are? Patrick?
2 numbers that have the same variable.
Okay, good. You're halfway there. Okay? Absolutely. The variables have to match. If the variables don't match, they're not like terms. But the second component to those variables is they have to have the same power. If the exponents are different, like in this example here we had 24v squared and 4v, they have the same variable, but they're not like terms because one has an exponent of 2, one has an exponent of 1. Okay? So like terms are terms, and it can be more than 2, terms with the same variable and same power. And so Michael's example of 2x and 3x meets the bill. So we're going to say check, but 4v squared and 2v doesn't meet the bill. Even though they both have v's, they're not to the same power, so they don't match up.
What's that in the middle?
And. Let's go ahead and do an example where you would be asked to simplify an expression. So let's go back here. Oh, nope, we're done with that one. So we'll go on, and let's change the directions. The directions would say simplify. Well, they're the same directions, but that's okay. And we have this problem, 17u plus 25u. So our job is to check out those variables to see if they are the same exactly. Same variable, same power? Yeah. So why is this applied to the distributive property? Well, again, I kind of mentioned that word factor. 17 and 25 both have u in common. So I can pull out the u. Now look what's left inside the parentheses. 17 plus 25. Can I do that? Yeah, I know what 17 plus 25 is. That's going to give me, what, 42? And I get 42u. Now, 17 and 25 have special a title that we give them. Does anyone know the word that we use to represent numbers like 17 and 25 in this situation when they're followed by a variable? You guys haven't heard the word coefficient before? Okay, you got to understand the word coefficient. I'm going to use it a lot. It is the numerical factor. Factor means part of a multiplication problem of a term. So if I have 3x squared, 3 is the coefficient. Okay? So I look at my problem, it tells me to simplify. I check to see if I have parentheses. If I do, I distribute. If I don't have parentheses, I look at, do I have like terms? If I have like terms, what did I do to get to my final answer? Joy? You do whatever the math it tells us to do, but only with the coefficients. Notice, nothing happened to the variable. The variable stays himself, okay? So that will be our third statement under combining like terms. You're going to perform the given operation with the coefficients only, and then I'm going to yell at you a little bit. In red, so you know I'm really telling the truth here. Variables oh, dear Lord. Never change. I'm pulling out that variable. He's stuck outside. Nothing is happening to that variable. Okay? Nothing's happening to that variable. Let's do another one. We'll do one more, and then I'm going to show you guys a kind of cute little video. Let's say we do this one. 4y cubed plus 2y minus 8y plus 5. By the way, notice that this problem is written so that the highest exponent comes first, then the next lower exponent, and then at the very end is a number with no exponent. That is called descending, going down, degree, exponent, order. That's how we always write our answers, regardless of how the problem's originally given to us. We write it in descending, going down, degree, exponent, order. Okay? So, look at this problem. Do you see any like terms in this problem? What do you see as like terms? These are the only like terms. So, here's what our problem looks like. I can't do anything with the 4y cubed. But what I'm going to do is to factor out the y from the two middle terms, and then nothing happens with the plus 5. So the answer is still has a 4y cubed. What's 2 take away 8? Negative 6. So I don't write plus negative 6. I just write minus 6y plus 5. And that's my answer.
How come you don't write anything?
Pardon me?
How come you don't write anything for the negative?
I did.
Oh, like minus.
Subtraction plus minus is subtraction. Okay? We only write one sign. Okay? All right, that's it. Let's got a video to watch.